I'm ready.
All right. Is it live?
Yep.
All right.
Nice voice.
Thank you. Thank you. All right. So we'll now do cryptocurrency safari, Bitcoin and behind. I will tell you more about it in a moment, but basically what we will do a quick, hopefully quick overview of Bitcoin and blockchain and what it really is, what is cryptocurrency that of course people keep hearing about. And the safari part is that as we continue, I will give examples of new coins that try to solve some new problems, and through that we will see how the field develops and really how cryptocurrencies are different from one another. So, alright, let's continue. So let's tell you a bit more about myself. My name is Mayan Keshet, I'm from Israel. I did my computer science degree in Tel Aviv University. I also studied about financial technologies at MIT. I did an executive course there, specifically about financial technologies. I also worked at SAP Research as a computer science researcher and at Dell Technologies. And today, what I do is cryptocurrency trading. So, analyze different cryptocurrencies, deciding what to invest. Part of it is developing algo trading, automatic trading for cryptocurrencies. So that's what I do today, and so we'll try to discover more about this world. So, okay, so as I said, basically our agenda will be like this. We'll start with what exactly is cryptocurrencies, what is blockchain, those words that we keep hearing about. We'll talk more about Bitcoin because it's really the first modern cryptocurrency, started around 10 years ago, and we'll continue to talk afterwards. So let's continue. Okay, so what's cryptocurrencies? Okay, so the name cryptocurrencies is basically comes from currencies and crypto, meaning currencies based on cryptography, right? The art or science of encrypting and decrypting data, of making coded messages that are secure, that are not easily cracked. So we'll go, of course, more about it in a moment, how it all relates to cryptography, but in an easy manner. But let's continue. Okay, what's the blockchain? So blockchain is literally, of course, a chain of blocks, which is really what the name means. So we'll see in a few more slides why it's called like that. Okay, so in order to understand how Bitcoin works and what is blockchain, we first need to know just a little bit about cryptography. And you don't need really any background in that, and it's not hard to understand it if you don't have a computer science background. So first of all, just as a name, there is something that is called an hash function, right? It basically just takes a lot of data and gives you a very small number as a result. So I don't know if you can see the presentation well or not, but basically you can see that there is a lot of numbers on one side and a very short number on the other side. And the idea of an hash function is that it's used for compression and things like that, and the idea is that if you change just a little bit the original data, the original numbers or text or whatever, then the number on the other side will be completely different. So, and then it's easy to see that the data is different, even if really one small number is changed, and the result will be completely different. Alright, let's continue. So of course we saw it with a number, but we can also see it with text. So as I wrote there, it can also be used for arbitrary text or data, like this sentence that we read now. So there we have this text on one side, and on the other side some number, some text, short text. Let's continue. And let's say I decided that I need to say it with more enthusiasm, so I now say it with an exclamation point at the end. And now the number on the other side is completely changed. So, where does cryptography plays into it? Because what I just said is now some sort of function. So, it's very easy in the general. Okay. What we are interested in, and that comes from computer science, is such functions, called hash functions, that are easy to make the tree from one side, right, from the to the short text or short number. And, let's continue. And then you have to do the opposite. So basically, if I'm the person that uses this hash function, I know what was the original text, I know what is the new format, but it's very helpful someone else that doesn't know the original code to really understand what it was. I mean, it's hard. What we mean when we say R in computer science here is that it will be unfeasible. So no matter how many computers you put on it, no matter how big of an organization you are, if it's done right, it's still only easy to make the trip from one side and not easy to discover what was the original text. So not easy to make the trip on the other side. So far, any questions about it? Feel free. Does that mean that everyone understands or that everyone doesn't understand? So, you know what, just for me for a moment. How many of you have heard of Bitcoin before? Please raise your hand. Heard of Bitcoin before? Okay, now many of you are using it. Oh, very good. I mean, yeah, of course Bitcoin is very famous, so I'm sure many of you have heard of it, but how many have not heard of it? Okay. So few people have neither heard or not heard of it, and the rest, alright, very good. Okay. So basically the blockchain is what we're going to talk about now and describe. So blockchain, many times when we go to conferences or hear lectures like this one, people say Bitcoin, blockchain, they use it very interchangeably, but it's really two different things. Blockchain is like a general idea, and Bitcoin is one implementation of blockchain. So what is blockchain? So you saw how I can take a text or some number and make it into a very smaller number that it's also easy to verify if I'm given the two parts, the original data and the solution. If I get both of them and I know what was the algorithm, the function that was used, I can verify that I apply this function to the text and I get the result and I can see that it's really okay, that it's the same result. So really what the blockchain is a series of blocks like this, where there is some first block and then we compute the hash function on it. Let's say the first action there is just some text that I want that everyone will know was the first action. Some text that describes an action, it's the first action that ever occurred. Alright. So and then I get another action. Now what I want to do, I want that everyone will know that the first action happened before this another action. So I just add to the another action, the text, I get 5f in that case, the result of this hash function. And why that's good, we'll see in a moment. And when we then want to add the third action, we just take the hash of this previous 5f, another action. And then we continue to do so. So basically what we get is sort of a series of blocks where the last block just contains the hash of the previous block, again, some very short number, and the new action. Let's continue. Okay. So why is it good? Because let's say I want to prove my friend that I have this series of actions. And I want to make sure that the first action is the first action, the second action is the second action, and so on. If someone wants to change one of the actions and make some sort of fake action in the middle, let's say he puts his own text, then it would the last action should have another hash, right? Because we always calculate the hash on the previous block, on the previous text, and when we change something in the middle, it really means that everything after that is changed as well. And it's because it's easy to make the trip one way, we can see that the first action and the actions after that don't really match the result that we get at the end. So you would get something else instead of D3 and that action over there. We would get something else. So we can see that something better. We can detect it. All right, let's continue. Okay, to understand Bitcoin and what really how we can use that, we'll need just to introduce another concept. It's a big name, public cryptography, but really the only thing that we need to know is that it gives. When people say that they use public key cryptography, basically what that means is that they have two keys, all right, two passwords. Like when you go to a website and select a password, so you just get two passwords. That one is public, everyone knows about it, and another one is a secret, only you know about it. Let's go on. And what you can do with those two passwords or codes or keys, anyone that sees your public key, the one in the green, can encrypt data using that key, but only you can read it with the secret key. And if you write something, if you post a message saying, oh, I declare that I was at this place, at this time, let's say, then you can use your secret key to sign it. And people can use your public key to verify it. So, how it is done is computer science stuff, and that's maybe less interesting for now. But that's really what it gives us. There is the ability, that's what we need to know, there is the ability to have two keys where one knows, where one is public, everyone knows about it, and another one is secret, just for you, for your own person. And that's how you can use it. So let's continue. Okay, so Bitcoin uses all of that to implement currency, to implement money. What do we really need to implement money? Let's think about this for a moment. So basically we want that everyone will have his own amount of coins, right? And I can pay someone with those coins. They can get money from someone. And it all needs to be secure, meaning that I can't, someone can't pay me money that he doesn't own. If someone has a balance of, 10 Bitcoin, and he already paid 10 to someone, he can't really pay anything else to me, right? I don't want to be in a situation where I run a web store or something, and someone pays me with Bitcoin, and then I discover that he never read this Bitcoin in the beginning. And I also don't want that someone will be able to change the history, right? That someone will be able to put in the history, oh yeah, I got $1 million from someone. So we will see how all of that is done, but basically Bitcoin is just uses what we've all discussed, as we will see in a moment, in order to create a currency. Okay, so we saw how with blockchain, it's basically just a series of texts or actions where every block includes the hash, or basically the hash of the previous block. And like that, it means that if anything on the middle was changed, then we can easily see that something wrong was happened, and we can then discard the last state, or discard the whole chain. I mean, this chain doesn't describe a series of transactions, that is correct. So basically, when I trade money in Bitcoin, or when you trade money in Bitcoin, when you send to a friend Bitcoin to his address, what's basically happening is that you say, okay, me, with a public key, some public key, like 1, 2, 3. You don't know, when you use Bitcoin and you use Bitcoin wallet, you don't know that what happens behind the scenes, right? But that's what happens behind the scenes. You have your own public key that is associated with your address, and that's what happens behind the scenes. So basically, you declare I'm with public key 1, 2, 3, gives 1 Bitcoin to the user with public key 4, 5, 6. And you sign it, and so then everyone that knows your public key can say, oh yeah, I can really know that that he signed it, and not someone else declared that he moves the money around. So basically, like that, no one else can make transactions on your name. No one else can take money out of your wallet. Now, there's also in the beginning, we can see hash of last block, meaning that whenever you make a transaction, then, of course, you add a transaction to a series of other transactions that happen in the vault, right? Up to that moment in time. So, in order to establish the order, like we did before with the blockchain, we just had to say, okay, this is the last block, but the block before me had the hash of I mean, in reality, it's much larger numbers than, or you know, much larger text than 5 bytes. Okay, let's continue. Okay, but we still have the problem that you want to make a system out of it. I mean, what I just described is still very amorphous, right? Still very abstract. Like, okay, I install a Bitcoin client on my machine or on my phone. Who does it contact? What website? I mean, what server does it go to receive the data, right? I mean, we need to make some sort of a system out of that. So there are servers in the Bitcoin world called nodes. If you heard about mining, which we will talk in a moment, so all of those miners or mining servers, that's basically what they do. People send them transactions. When you want to move money to another person, you basically notify all of the nodes that you want to move money. And what those nodes do, they take all of the transactions together and just gather them, verify that they are okay with those rules that we just said, with the hashes, all right, with the ability that from computer science we have. They verify that no one added some transaction that isn't valid with the history of what happened until now. And that's it. Say, okay, this is all of those transactions are good. I declare that this is a block of good transactions, and then continue. Okay. But what I just said is, okay, so there are many nodes, okay? There isn't one node in the world of Bitcoin. Why? Because the whole idea of Bitcoin is to be decentralized and distributed. What does it mean? It means that there isn't one bank or government or one organization or something like that that has that does all of the verification. That means that no one organization or person can manipulate the records, right? So once someone did a transaction, and it was verified with what we just described, then okay, that transaction is there forever. No one else can now modify it. So now comes the question, okay, so but if there are so many nodes, how do we know that someone doesn't install some computer program on his node that actually gives me bad results? Like how can I trust it? Because and what happens if that's the situation, right? What happens if many nodes give many different answers? How do we what do we do in this situation? And another thing that can happen is that you know, two transactions happen really at the same time, and two nodes receive different transactions at the same time, and both of them say this is the last block. So we need to have some sort of a canonical history, right? We need to have one history that everyone agrees on. So if I transfer money from Croatia to India, and now that guy on someone else at the same time sends money to that guy in India, we need to decide which transaction happened first. Okay, so that's going to be... no, sorry, let's stay here. Okay, so the solution to that is what is called proof of work. So what is proof of work? Basically, what we say is that every node is not just doing the verification. I mean, it sounds complex, all of the verification stuff that I just said, but computers can do it very quickly. But in order to... But what's the danger? The danger is that one big organization or someone that wants to manipulate the markets or something like that will put a lot of computers, a lot of that are connected to the internet, all of them will be nodes, and it will receive a lot of transactions to verify, and they will just say, oh, this transaction is bad, even though this transaction is really good, and it will add some transactions or do things like that. So how do we prevent it? So the solution is proof of work. Basically what proof of work says is that we do all of the things that we have just said, but in addition, when you do the verification, you need to solve some very complex mathematical question, okay? And this complex, this really means that you need to have a lot of computer power to solve this mathematical question. And how Bitcoin works is that the more time goes and the more computers join to do this verification. In a moment we'll see why even someone would want to connect this computer to the internet and do this verification. But the more they are, the harder this mathematical problem becomes, because that means that at no one point in time, one person or one organization can have a lot of computer power do the verification, because if someone would need, want to control 50% of the computing power of Bitcoin, do 50% of the verification of Bitcoin, it means that he also needs to solve 50% of all of those hard questions, right? Hard mathematical questions. That's actually very, very, very hard, infeasible for one person to do so. I mean, when I say one person, it can really also be the NSA or some other big agency or corporation. So basically what happens is that this is the same slide that we had just a moment before, where we gather the last transactions that we saw and verify them, but in addition we have a solution to our problem 5. In the next block maybe the solution will be something else. Now this mathematical art problem has an interesting characteristic, an interesting feature that is similar to something that we saw before. It's very hard to calculate it, but it's very easy to check that it's correct. So that's also why when someone does the verification and says, oh yeah, the answer is that, then we can easily see that he's not bullshitting us, right? And when I say it's easy for us to see that he's not bullshitting us, it means that other software, other computer programs, other nodes all check one another, and the Bitcoin clients, when they check the history, they see that they also do this very quick check that everything is okay and that what they received is correct. Okay, let's continue. Okay, so maybe one more note. So if we'll just have a summary of what we saw until now, and maybe that will put now things more into order. When I install a Bitcoin client on my machine or on my phone, and a friend sends me my first Bitcoin, what happens is that his Bitcoin client, his phone, his computer, sends a transaction to all the nodes of Bitcoin. They start they add this transaction to the block that they are currently working on, to the block that they currently gathered. They make. In the meantime, they search for the solution for this hard problem. Now, it's really, what I'm about to say may sound weird or fantastic, I don't know, but that's really how it is. To solve this hard mathematical problem, you can't really know how much time it will take you. It can take you 5 seconds, or it can take you 10 minutes. So it's really a matter of chance and the computing power that you have. I mean, in theory, even one small computer can, by chance, get it in 5 seconds, and someone with a lot of computer power can get it, can maybe never stumble on the solution. But it will have better chance. That's how it happens. Okay. So, let's say. And once some node in the world happens to both gather large amount of transactions and find a solution to this hard mathematical problem, then it declares to the node, oh, I found a solution to the mathematical problem. The block that I worked on until now is this block. These are the transactions. I verify that these transactions are okay. And that's it, all the nodes accept it. That's the protocol. And your Bitcoin client sees it because it is connected to some node. You see that these nodes suddenly have accepted a new block, a new part of the history. can also verify that this new history is okay, because you can see that the solution is not a bullshit solution, but it's a good solution, because it can easily verify that that's what happens. And that's how it works. And if by chance we have the example where two nodes on the same time find a solution, which in theory may happen, then basically what the protocol says is, okay, let's wait for the second block after that, and so on, because of what I described, that it's really random, the ability to find a solution to the problem. It's dependent on the computer power that you have, but it's still random. It's very, practically it almost never happens, and it really will almost never happen on the second time, and so on. Okay, so that's how Bitcoin works. That's it. Now, I mean, there are some nuances, there are some simplifications that we made here, but that's even complex enough as it is, but that's really how it works. So what's the problem? Okay, before that, let's see some of the features, some characteristics of this proof of work, because it will help us to see something later. So it takes a lot of power. I've discussed that basically you need a lot of computer power to really participate in that. And that's sort of a feature, because it means that no one has enough power to really do something bad to the network. Also, the reason why someone would even put their computer in the network and make it be used as a node, he has to have an internet connection, he has to have a strong computer, he has to use a lot of electricity for that. The reason that he does that is that he gets rewards. Basically, on every block that you successfully push to the network, you get a nice reward. And also the fees. People pay fees when they do transactions in Bitcoin or in other cryptocurrencies. They decide on some fee that they want to pay. Now, if you use a wallet on your phone, usually you pay some default fee that the maker of that software decided that is good for you. But it's always happens, you pay some fee. And so he takes all of those fees, he takes this reward, and that's his incentive for when act as a verifier. Now, another characteristic of that is that this is used as a small amount of inflation in the Bitcoin world, right? If you think about economics, the Bitcoin started with some number of coins, and then like a central bank or a bank in a country slowly prints money. Then also in Bitcoin, you slowly get money, new money to the system through those rewards and fees. Basically, those rewards are the only way that new money that wasn't existing before enters the market. And that's a good property. I mean, we can't discuss it now because it's like a macroeconomics question, but that's a good property. Okay, so this verification is what's called mining, because the metaphor is that because this is how new coins are made, then it's like mining for gold or mining for diamonds and finding new gold and finding new diamonds. So the metaphor is that you find new coins, and those coins are really reward. And it's resistant. I put in sort of, and we'll see why sort of in a moment. So let's resistant to changes, right? Yeah. So what's the problems of proof of work and of Bitcoin by extension? Is that it uses a lot of power. So I said that it's a feature, right? That it's good because no one person can use the power. Now, of course, that's why we've decided. That's why it was made like that. But still, it sounds very inefficient. Because what really happened is a race. I mentioned that people get rewards, right? And they also mentioned that the more computing power all across the world people put into this mining process, the more difficult the problem becomes. That means that really, today, people buy big computers with lots of processors, lots of graphic cards.
There's a lot of graphic cards on the market because of
exactly.
They are more expensive than before.
In the States, for example, I don't know the situation now, like last week, but even a month ago, there was a shortage of graphic cards because everyone buys graphic cards to do mining.
Good for NVIDIA.
Good for NVIDIA, good for AMD. The stock rising accordingly. But the issue is that it also, but it sounds inefficient because really what it means is that, people use a lot of electricity, burn coal, it's not ecological, right? So thing is that it favors big players. So, and that's also why the resistance, sort of, which I will mention in a moment. So, you know, for a private person, originally when Bitcoin started, cryptocurrency started, to gain enough rewards to make it, you know, financially viable for someone to put in his computer, you really had to have just a small computer, all right, even a laptop or something. Okay, and then more and more people started to participate, and then you need a stronger computer, maybe not a laptop. And then people found out that you can use graphic cards to actually make it much more faster. And once that happens and people start to use graphic cards, then all the people that don't use graphic cards really don't get enough of a reward. That's how it works. And so now you have to have a graphic card to participate. Okay, but then people discovered that you can use 10 graphic cards at one time. Like you can buy huge computers. And let's move one more. And in the case of Bitcoin specifically, you can use specialized output. Like if you're a big corporation, you can even do something that is much more better than graphic cards. You can put a team of engineers, and they will create special cards for you that do calculations that are special just for Bitcoin, for those hard mathematical problems that Bitcoin uses. And they're really orders of magnitudes better than anything else on the market. Now, of course, it's much more easier to a huge company to either buy, you know, huge computers with many graphic cards, or to invest money to create very special hardware to mine Bitcoin, right? It's not something that just one person can go and do. And that means that it favors big players, which some people think may be unfair. That's also a big part of the issue, but it's also not very secure. Because in practice, I mentioned that no one person can have a huge amount of power to influence the network, right? If you know, I didn't mention it here, but to have the network secure, that no one person can manipulate the network, you have to have that no one person have more than 50% of the computing power. That's some statistical or mathematical calculations that people have done. But you know, in practice, if you take the 3 biggest mining companies, Bitcoin mining companies in the world, all of them are located in China. Together, they control about 60%. I don't know if it's true today, and at some point it was true. And you know, if they all decided to collaborate together, in theory, it would still be very hard to do this in practice, right? But in theory, they could maybe do something when they have that lot of computing power. All right. So that's the problem with proof of work. Now let's discuss the other problems that Bitcoin has. That all of those problems are addressed by other coins, that's why I'm talking about it. So another thing is lack of leadership. Bitcoin was started by, was published in 2007, I think, but look it up if it's important to the exact date, by someone named Satoshi Nakamoto. Now, it's not a real person, and no one knows who is really Satoshi Nakamoto. There were some claims by some people, but nothing that seems real. No one has a good evidence that he is the person, or that someone else that he claims is that person. So really, no one really knows who is the person that published the paper that Bitcoin was implemented after. And that really created sort of a community where there is no strong leadership or someone who guides the system. Now, it's both good and bad. Some people like it. They say, okay, so there is no one leadership, so everyone can do what he wants, everyone can develop on the platform however he wants. All right. But in practice, it also means that when there are problems in the network, or problem in the protocol, or new developments in the field, there is no strong direction. And what happens is that there are different factions, and you know, everyone wants to pull to a different way. And I will remind you again in a moment. So all of those things that we have discussed are good and well, but you know, in practice, you also have limitations of software engineering, right? We saw the blocks, right? The blocks that miners or verifiers gather, blocks of transactions. So, for example, there is some limit on the number of transactions that can be done per block. Just it was set in the beginning. And that means that now that many people use Bitcoin, much more than 10 years ago, it's actually not enough. It makes the system slow when many people use it. How slow? At the worst of times, it would really take 12 hours to move a transaction. We are talking about a technology where the big promise is that you can move money instantly from a place to place, right, from one corner of the world to another corner of the world. Also many use cases, business use cases are about it. If we think about the future, where we will have self-driving cars, and the self-driving car can go to a garage and tell the garage, oh, fix me this and that part, and I pay with some electronic money. And maybe you say to your car, fill up gas up to $50 per week, and your self-driving car drives and fills it with a Bitcoin or some other cryptocurrency that it has on it. All of those things, if we really want to have some feature like that, then you need to have very fast transactions and very low fees for those transactions. And both the speed was reduced and the fees went much higher, because when the speed is reduced, people are willing to pay more money to have the transactions happen fast. And that means that there's sort of a rise of the fees that people are paying. And all of those making a lot of problems. So currently the average time that it takes for Bitcoin is 25 seconds, which is not as bad as the 12 hours that I just mentioned, but it's a problem. So what I just mentioned with the block size, maybe just you heard about block size in Bitcoin, I don't know. If you read some things about it and people say block size. But never mind, the idea is that there is some technical difficulty. It has been known for 2 years, even more. The solutions for the technical problem are known, but for 2 years there wasn't any. Everyone wanted to implement it in a different way. So you have a faction that wants to implement the same solution, but in some way. And then another faction that wants to implement it, sort of the same solution, but in a bit of a different way. So there are reasons why you would want to implement it like that or like that, but if it takes you years to really move, right, as a technology, it's a problem, because other people will do. We do things better. So, that's my view. I'm sure that many people in the Bitcoin community, for example, will disagree. Alright. And then, when I say semantics, there is another problem in semantics. So, Bitcoin is for transferring money, alright? There are many other things that you could do with blockchain. In the beginning, I didn't say that blockchain is just for currency. I said that blockchain is about actions and the order of actions. So you could think maybe about other things that you could do with blockchain, as we will see in a moment. But Bitcoin is for money. It's very hard because of that to do other things with it. It may be possible, but it's very hard. Okay, so let's continue. Okay, so now we'll get, I will, now the talk will hopefully proceed quicker, because now we basically will talk about small features of some point, and we will see what it is. By the way, any questions until now? Feel free. If you have a question, then it means that probably other people have it. Yeah.
What's the connection between anonymity of transaction and the transaction history that claims?
That's an excellent question, and in fact, it's the last slide that I have, so we'll reach that. Because maybe I will talk about it more at the end, but Ivan is correct of pointing out that everyone has the history, right? Or at least the history is public. All the nodes have it, and if you want to run a node on your own computer, you can download all of the history. So you can see, this account transferred money to this account, and this account transferred money to this account. So on one end, those accounts are just numbers. You don't necessarily know that that number belongs to Ivan or me, but it also doesn't sound as private as people think that it is, or as not as much strong anonymity. Okay, wait. So let's continue with that. So what is smart contracts? I mentioned smart contracts. So smart contracts, another idea of application for blockchain. Basically, instead of just using it for money, we use it for contract between people. Instead of saying that I signed that I now transferred money to someone, I say me with public key, whatever, right, with some account, agree to pay another account 100 points if CNN.com shows that this and this team wins. I don't know, we bet on some sports game. And it's possible to do so. Now, it's important to see two things here, or several things. One, is that those kind of agreements until today were done with a third party, right? Either a lawyer or a gambling house or something like that. Or, if you buy houses, then you pay escrow, and the escrow service saves the money and doesn't release the money until a lawyer is confirmed that everything happened according to plan. Here we have an agreement where there is no judge and no lawyer that enforces it, and yet it is enforced by the blockchain agreements, by software. So it can revolutionize every kind of business that requires a third party for trust, where you don't trust the other person that you make the contract with, and you need a third party to enforce the claims, enforce the contract. Because, if I made a bet like that with someone, even if I see that I'm going to win, and I tell him, I do this bet with Ivan, and I say to Ivan, well, you know what, I see that I'm going to win, but it's okay, you don't have to pay me. It's impossible, technically. Once the game happens and CNN.com does something, then that's what I will get 100 points. Another thing that is important, okay, let's move to the next slide. Yeah. So that's the huge potential, right? Because, imagine that you want to do a business that provides much lower fees for managing stocks and things like that when to give to your children when you die, all right? So basically what people do today, they go to a lawyer or an accountant, they set up some account that they manage, and then in the meantime they take you a lot of fees, they take a lot of money. Then once you die, maybe they wait until your child is 18 years old, and they still take fees. And then if the agreement that you made with them is, you don't know if your kid will be financially responsible or not, so you tell them just give him not all the money at once, but pay him every month something. Then they also manage that and also take fees. Okay, now all of that you could just do with smart contracts and with something like that. And you don't pay a lawyer, you don't pay an accountant. So people all over the world now see this as a huge potential for business. Okay. Now, what are the problems with that, or features, It's very complex. It's very, very easy to make, when you program something like that, it's very easy to make a mistake. And also when you program a smart contract, it's like a contract with a lawyer, where you could find maybe some loophole that the contract didn't think about. It's the same with that. And because it's not enforced by a judge in the real world, it means that if you made a mistake while putting in the contract, even if a mistake seems unreasonable, that's it. So that's a problem. It's complex and it's easy to make mistakes because it's complex. Second, another thing is what we call oracles. It's not a problem, it's just an issue that people need to think about. What we mean in that business when we say oracles is that I said here, okay, if CNN.com shows that the team won, that means that I trust CNN.com, right? But I just told you that the whole idea of smart contracts is that I don't need a third party, that I can just do something with someone without a third party involved. In practice, because you still need some real-world information, like stock prices, car ownership data, land ownership data, sports team results, sports game results, things like that. In fact, you do need some data source, and you do need some data source that you trust. When we speak of data sources that we trust, the term is oracles, right? So just if we hear about oracles, that's what it means. But that's a problem, because we want to have, we want to have sources that we don't need to trust implicitly. Okay, and another thing is that it's computation heavy. So in what we mentioned with Bitcoin, is that the verification process and everything is not, it's not really computationally hard. But the proof of work, the mathematical problem, is very hard. Now this adds another layer of computation, which is executing those smart contracts, going to CNN.com and check what happens there, doing many other things, and okay, it's also adding computation. Okay, here's a computation. So I think that it would be true to say that the front runner on that game smart contracts today is called Ethereum. strong leadership. The organization that makes it already has agreements with JP Morgan, UBS, banks all around the world, firms all around the world. And they really push it forward. It also gives way to a very good standard. I mean, a standard is called the ERC20, but when we say what we talked about smart contracts, I gave the example of a bet that I can make, but I can also decide that I create my own coin, right, over Ethereum. So now that I want to create, let's say I want to create and make a new service, I call it my own service, and in order to use that service, you pay me in some ION coin or something, a coin that I created. It's easy to do this on this framework, on this environment. So that means that we now have a standardized way to create coins, and if I buy some hardware or something that stores coins or that uses coins, or I make software that people can use to transfer coins to one another, I now have one standard that I can program with, and not millions. If they use that Ethereum blockchain framework. And okay, they have a very good roadmap, a very ambitious roadmap. In fact, most of the things that we will see in a moment, they want to implement in Ethereum as well. It's part of the roadmap that they have. And they showed very good execution ability. So things that took, for example, to the Bitcoin community 2 years to just figure out that what they want to do, were already implemented quickly in Ethereum. So it gives confidence. All right, that's okay. Okay. We've discussed proof of work, we've discussed the problems with it. There is another concept that is called proof of stake that just introduces some interesting things, and so it's, I think, important to talk about. First of all, what we're doing by stake or staking. So let's say that I have now 100 Bitcoin, all right? And I want to prove someone that, or some other coin, right? Ethereum. Bitcoin today, one Bitcoin is worth $4,200, $4,200, right? $4,200. Ethereum, currently one coin is worth $330 per coin. It's not really one coin per one coin, because you also need to check how many coins are in the market and so on if you really want to check that. Never mind. So let's say that I have 100 Ethereum. Alright, and I want to prove someone, I want to prove Ivan, I'm serious in doing business with you. So, in order to show you that I'm serious, I'm going to stake, I'm going to put on the side 50 Ethereum, and I will receive them back only if I'm, only if we see that I'm doing all the things that I said that I do. Or maybe even I just say, okay, but I will receive this money no matter what, but in 4 months. So, if I don't mind putting a large amount of money for 4 months on the side, just to do business with Ivan, maybe that means that I'm serious. So that's an idea that people use in order to do some sort of reputation, to make some sort of reputation in the crypto world. So that's what we mean by staking. Now, so what we do in proof of stake. Hello. Okay. What we do in proof of stake, instead of making nodes solve some hard mathematical problem, we basically say, okay, you don't need to solve the complex mathematical problem. You just need to do the verification, which is very easy. You can even do it with a laptop at your home, right? But you have to put a lot of money on the side, all right? You have to take 50 Ethereum and put it for 4 months on the side. And so let's say that the number of all Ethereum that people put on the side is 1,000 altogether, and then you would now put 100. So 100 out of 1,000 is 10%. So you will get 10% of the verifications. You will get a chance, all right? Someone will be chosen by random, but random that is proportional to his stake, all right? So if I put 10% of all the Ethereum that people put on the side, I will get the opportunity to do 10% of the verifications with the rewards that we talked about, right? Rewards and fees. So that's what I will get. And I can do it with very simple computation. It doesn't take a lot of computing power. It doesn't take a lot of electricity. It's very ecological, very efficient in the sense that it doesn't take a lot of money to do that. You don't need to pay the electricity and the bills. And so that's like a very good idea. Now, there are some nuances. One is that it's not immediate. I can't immediately create a new coin and say, okay, but this is just proof of stake. Because I need, if I just start a new coin and just a few people have all of the coins, then maybe one person will have, over 50% of the coins, and they will get, in essence, 50% of the verifications done, so we can manipulate the network. So really, it's only for coins or blockchains that already are established in some way, that the coins are well dispersed. So maybe Ethereum, for example, is started with proof of work. It's still proof of work. In the meantime, they implement the proof of stake, and at some point, they will move to proof of stake. So it's good for blockchains that are already mature. And it really creates something that is like a bond, not James Bond, but the bonds that you can buy from a government or a corporation, where you can put money on the side and receive a dividend or interest or something like that. So that's also very interesting for large investors and things like that. Okay, let's proceed. Okay, I just, transactions and trading channels, Omar. So all of those are big words, and they are topics that are complex, but I just want to mention them. So the problem, one problem is that Ethereum, Bitcoin, all of those, at the end of the day, they don't want to compete just between themselves, okay? They want to compete with Visa, okay? They want to make an alternative for MasterCard. That's what they want to do. But Visa has something like 300,000 transactions per. 200,000? Okay, 200,000. Anyway, but the order of magnitudes of hundreds of thousands of transactions per minute, right? Second, right? I don't remember now my own order of magnitude. That's good. Bitcoin, for example, does something today between 3 and 7, all right? And on average, and Ethereum 10 to 15. I mean, those statistics may be a bit outdated. Maybe it's from a few months ago, but. This is still the order of magnitudes that we're talking about of difference. So people want to do a lot of technological advances to make it quicker. One of the proof of stake that we discussed is one of them. Another one is called sharding, which just means that not all the nodes will manage all of the history, but some nodes, different nodes will manage different part of the history or different number of accounts. But that's really hard to do in practice, okay, for various reasons. And channels basically just means that instead we saw about signatures, right? That I signed that I did this and this transaction. So and everyone verifies it. Everyone verifies that that's really me that signed all the nodes. But in theory, maybe I do a lot of my business not with everyone, all right? I transfer a lot of Bitcoin or a lot of Ethereum or a lot of money to just Ivan, let's say. Because Ivan is a big supplier of things that people buy on the dark net, things that, I don't know, gaming site or, I don't know, pizza delivery, right? Pizza delivery by Bitcoin or something like that. And he does a lot of business with people, so he could see that he doesn't need to try. I mean, not everyone now in all of the world, all of the nodes in all of the world need to check that Ivan really has the money that I have. If I do a lot of business with Ivan, he has this information across time, right? And so maybe if I do business now with someone else that does business with Ivan, he can, instead of asking now all the nodes, and now all the nodes need to answer to him, he can just ask Ivan, and Ivan will tell him, yeah, Marian has, I know that he has enough money because I paid him a week ago. So that's the idea, okay? I mean, it's a bit ambiguous and amorphous, but those are because those are big issues with many nodes. So the idea is that people are working on that. It's still nothing is perfect in this area, but that's something to do. Okay. Okay, privacy. So What's the issue of privacy? Okay, so people tell you, okay, Bitcoin is anonymous, right? There were websites, right? Big websites on what we call darknet, like Alphabet, Silk Road, things like that, where people, I don't know, buy drugs, guns, pharmaceuticals, I don't know, fake passports, whatever. And they say it's anonymous, and that's great. But as we saw, it's not totally anonymous, right? Because the history is published, right? So the history of all the transactions is published. If I know that, I check my friend's address on his wallet, and I can see the history of the addresses that he uses on his wallet, and I can then use those addresses that he uses, his account number, to see what he done, all right, and where he paid. And if I know that another address that he paid is used by someone else, then I can establish that he sent this person money. So it's not as private. So basically, people have many different approaches of how to deal with that, but so we'll see two of them. Let's continue. Yeah, so another one, okay. So maybe before I mention that, I'll just mention something that people do in the Bitcoin world, because it's very similar to what we are about to discuss. So there is something that is called mixing, an action that is called mixing, where basically it's a service that I tell the mixing service, I will send you now 100 Bitcoins, take your fee from that, and send all of those Bitcoins minus the fee to some other address that I will tell you. Now, because many people do that together, send it to this big mixing service, then it's very hard to see the connection between between you to the person that you want to send the money to. That's called mixing, because you mix the coins of everyone together. So there is a cryptocurrency called Monero. They weren't the first to use what I'm about to say, but they are, I guess, the most successful of the people that use it. Which basically says that instead of saying, I, with my account, send the money to this account, what they say is they take some people together. I now want to send money to Ivan, but basically it takes many accounts from the system, and it says, I mean, how it does it is a bit more complex, right? From a computer science background, but what they say is someone from that group, from a group of many accounts, sent money to that user. So now, I know that Ivan maybe sent money to someone, if I see his account number there, but I can't really know. It's a bit of a simplification of how it works, mathematically, but that's the gist of it. So it basically gives even more plausible deniability about what you know. Okay, I mean the technical term for it is really simple. It's really interesting someone or videos on YouTube and things like that. Okay. Okay, now zero knowledge proofs. All right. So zero knowledge proofs, it's something that really could take computer science a semester to study properly. But the idea is basically that instead of really declaring what I'm about, I just want to mention the idea, right? Because it's something that people will hear about, and it's interesting to know the possibility. So zero knowledge proofs. Zero knowledge of ZK. I don't remember what snark is. Do you remember what snark is? I don't remember now. Google it there, people at home. And basically the idea is that instead of saying that Ivan instead of saying that he will send someone money, instead of saying Marianne, I will send you money, and this will be on the public blockchain for everyone to see. He will just send me a proof that he sent me money. Now it sounds weird, right? What does it mean? So a good analogy to that would be which basically is, so the V and P is, because I took it from somewhere, is, my apologies for the person that made it, but if you search for ZK snarks, you will find the presentation, which is, he expanded it in more detail. So the credit is to this anonymous person. So let's say there is a Vlad and Petra, and Petra enters a secret cave, and she tells Vlad, there is a door in the middle, right, at the line over there, and I know the secret code to this door. And I want to prove you that I know the secret code to the door, but I don't want you to know the code, so I can't have it with me when I open the door. So how would she prove to Vlad that she knows the code without really showing him the code? So she could enter the cave. Let's say that there's two directions, one from one side of the door and one from another side of the door. So she goes to some arbitrary, right? Some random. She flips a coin and goes to A. And then that goes inside and gets B. And now, if Petra really has the key to open the door, that she opened just before Vlad entered, so you can't really know whatever, how she opened the door, then she could go either from A or from B, right? I mean, she could go from either side. So, you know, Vlad does it one time, and he sees that she really comes from B. Now, he doesn't know if she was originally in B already, right? Maybe she was originally in B, so she didn't really need to open the door. But if he does it enough times, all right? If he does it 10 times, 20 times, 100 times, the chance of her really being able to every time be in the exact location that he has is very, very small, right? Because she could only really do it in a plausible way, right? You could calculate the chances that she had to do it. You could see that it's very quickly, she could only do it in a 99.99% chance, only if she really had a key to the door. So that's sort of a metaphor of of a zero-knowledge proof, right? You can supply some sort of a proof that that you have a solution to something, and you can check that proof enough times so that without really giving the whole program or giving the whole your whole secret, you can show that you done something. So, of course, I know that that's very amorphous, but that's a fact. But the idea is that if someone is really interested in the privacy of blockchain, then that's a very interesting area of research. Zcash is okay. You don't see the cache because it's left. So Zcash is sort of the first, I think, that did it in a wide web. By chance, one of the creators of Zcash was a professor of mine at the university. By chance. Okay. Another thing is that, if you, I don't have a slide for that, but it's important and will be the last thing we speak about, is stability, right? Everyone that is even a little interested about cryptocurrencies or hear about cryptocurrencies knows that, Bitcoin started from, 2 cents and then rose to 10, and then rose to 100, and then rose to 1600, and then plummeted to 200, and then went again to 2000. Then again to 4,000. I mean, the difference is very, very big, right? And that really means that if I pay someone now for his services, maybe by the time that he gets the transaction, it really suddenly worth a lot less money or a lot more money, and I would feel cheated, right? That's a problem. And people try to make stable coins, okay, that's the term, stable coins. That their value is consistent over time. I mean, similar to the dollar, to the euro. It's not an easy task for many reasons, but that's sort of also something that people work on, stable coins. The idea is basically that if the price of the coin rises too much, too fast, then you make the inflation higher, right? The rewards that we discussed about, suddenly make them very big, and so because suddenly there are much more coins, the price goes down, and vice versa. If the price goes down too fast, then you burn coins in some way. You take out coins of the market, and suddenly the coins become more expensive. But that's the usual approach people take, but that's anyway, so that was about that. Any questions? I mean, feel free to ask anything or about that. Ivan, please ask a question.
Well, it's a huge rabbit hole to explore, so...
Yeah. Of course, every one of those things you could have a whole lecture about just the users, but I want to give a quick overview of, maybe the first step was hard, I don't know, maybe hard for some, maybe too easy for someone else if they already know the area, but if you found it too complex, then you can go back and replay it, I'm sure it will be become clearer. But I just want to give an overview of what people are working on and what are the different, cryptocurrencies, what's the difference between Bitcoin and one thing and something else, and that's basically the differences between coins. So, thank you very much.
I'm going to name my graphic card Alice.
Well, sorry again?
I'm going to name my graphic card Alice.
Alice, very good, very good. From Alice and Bob.
It's a big rabbit hole.
Yeah. Very good. Yeah, true. All right, so thank you very much. I hope you enjoyed the journey from the lecture. Thank you very much again.
Thank you.